Hi, my name is Enzo. I'm a founder of Dental Tech Expert, and today we're going to cover probably one of the most exciting papers that we came across over the past 2-3 years. But before we deep dive into that, I'll ask you to subscribe to the channel, like, do something with this video. Let's talk a little bit about 3D printing, especially about ceramic materials 3D printing, right? There's no doubt that 3D printers have been the technology most adopted especially over the past 5 years, right? Mainly because of costs and flexibility of portfolio that you can get with a printer. But so far, printers have been limited to working with resins. What that means, working with provisional cases, working with light splints, working with surgical guides. So nothing with a high value added to that. What this paper covers is what has been discussed on the market for a while, which is ceramic 3D printing. The problem with ceramic 3D printing as of now is that we have three main hurdles to cover. Being those three: first, equipment costs. Yes, there are technologies available to 3D print a zirconia or a lithium disilicate. The issue that the printer alone costs over $200,000 US, which makes not accessible for 99.9% of the operations out there. Number two, post-processing time and energy consumption. And here what usually happens is between printing, after you finish printing and you get it ready to do a makeup or a layering on it, you would spend over 100 hours, again, making it not a reality for 99, maybe 100% of all operations out there. Number three is the surface and aesthetic finish of those crowns. This paper was done by the University of Texas, and what it covers, it doesn't solve, but it gives us some insight on how to solve the first two ones: equipment costs and post-processing time and energy consumption. Let's talk about the costs first. Remember I said that those printers, they would cost you $100,000 to $150,000. On this study, they used a Teflon 3D printer that cost $22,000 MSRP. The resin that they used costs only $1,000. This might sound like a lot, but when you break down the cost per crown, we're talking about a $2.50 cost per printed crown. This is maybe 25% of the cost of a milled crown. That's a game changer for sure. Now let's talk about number two, which is the post-processing time and energy consumption, which was the main focus of this paper. Why does this process take so long? There is a process called debinding. What is this that the crown has to go through between printing and sintering? It has to debind. The binding on the resin is the polymer used to bind everything together. And before you can actually sinter a zirconia, you have to take all this binder out. And this taking the binder out, surprise, is called debinding process. There are many ways of doing this debinding process, but the main one used for these type of applications are thermal debinding. Basically, you burn out those binders. So far, the method that the industry has used to debind those materials has been a slow heating cycle that takes over 100 hours and does not go over the sintering temperature. This study proposed a ultrafast thermal debinding process. What that means is that they created a custom setup that involved a graphite healing element, high energy source, a vacuum chamber, and a pyrometer. Check if I'm saying that name correctly. I'm not going to break down the whole chemistry, physics related to it, but what's important is that they took that 100 hours cycle and they brought it down to 30 minutes. And this is not only the debinding process. We're talking debinding, burning the binder, and sintering in under 30 minutes. Just think about the real life applications of a technology like that. Imagine you can print 40 crowns on a standard printing plate. You take those 40 crowns, hopefully put them all to debind and sinter all together, and you have, in 30 minutes, 40 crowns ready to start the finishing process. If we do a simple comparison of that with the currently technologies available, milling machines. With a milling workflow, it would take you easily 16 to 20 hours to get all that milled, sintered, and ready to finish. With this 3D printing, ultra-fast debinding process and sintering, you could get the same amount of crowns ready in 30 minutes. That's why, in my personal opinion, this is not a solution for an in-house lab on a clinic that wants to do same-day dentistry. We've had technologies for this for a while now. Even if it's a CEREC system, if it's a same-day Zirconia system with ultra-fast sintering, we have technologies for that. But having that volume at that speed is definitely a solution for mid to big size labs. Of course, this is not yet a commercially available technology. I think it's the first paper that we came across that actually covers and proposes a solution for that. The main challenge is making an equipment for this post-process that is commercially viable. Once that is done, we're definitely gonna see that technology becoming more and more adopted throughout labs. If you have any questions on digital dentistry, or if you have any ideas that you want to talk to us about, get in touch with us.